Assalamualaikum to Dr. Ruhaidah. Today we are going to present the mini project and we choose option 1 for our topic, which is convolutional neural network. Meet the team that consists of ALIAH, Aida, ATHIRAH and me myself Hanisa. The objective of this report are to identify the full definition and concept of CNN, what layers that make up the CNN architecture, and how this neural network operate based on the architecture. And the most important is to know how the CNN apply to the real industry and field. Without further ado, we go to the introduction of CNN. What is actually the CNN? As we may know, CNN is a class of deep learning, same like ANN that we learned previously. But CNN more focus on image tasks such as face recognition and classification, face detection. Also, not only the image focus task, but voice recognition is included in the application of CNN. Like other neural network, CNN also have its own advantage. CNN able to learn the filters automatically without mentioning it explicitly. Besides, CNN can capture special feature, and this is great advantage because it helps us identifying the object accurately.
Next slide is about task distribution. This diagram shows the timeline of our project. We start the project from the 25th of May 2020 until 27th of June 2020. In 25th of May 2020, my group have discovered the project topic which is given by the lecturer, and also we have distributed the tasks between each member. For the 1st June 2020, we need to start to write the proposal in the Google document. After 2 weeks, all the members need to make sure that the main subtopic given to them have written in the Google document. It doesn't mean that each member need to finish up the task, but at least the main subtopic have the point stated. For the 22nd of June 2020, my group have submitted the synopsis of the project to the lecturer, and lastly is 27th of June 2020. We have summarized the proposal and do the video presentation. Next is the tools used. In this project, we have used 4 tools to finish up the task. The first tools is the Google document. We use the Google document to write the project proposal. The second tools is the web browser. We use the web browser to access the references of the project. And the third one is the Microsoft PowerPoint, where we use this PowerPoint to do the presentation slide. And the lastly is the Zoom Cloud Meeting, where we use the Zoom to record the project presentation. Architecture of CNN. This diagram shows the architecture of CNN. In CNN, it consists of 2 layers, where the first one is convolutional and pooling layer, and the second one is the fully connected layer. Convolutional layer. Convolutional layer is the first layer to extract features from an input image. It functions to preserve the relationship between the pixels by learning image features using small squares of input data. The operation for the convolutional layer takes 2 inputs such as the image metric and the filter, were known as the kernel. This is the diagram of the convolutional layer. The first one is the first input, which is the image metric. The second one is the second input, which is the filter, and the last one is the output. For the image metric, we will use this operation, which is the H times W times D. For the second input is the filter, where we use the equation of FH times FW times D, and the output will followed by this operation. And this is the example of convolutional layer, where The first one, it shows the 5x5 image, where we know as the image metric, will times to the filter image, which is the 3x3 image. And this image shows the output of the metric for the convolutional layer. While for the pooling layers function to reduce the number of parameters when the images are too large. And this is the example of the pooling layer, where this is the 4x4 image. It consists of 4 parts, which is the red part, green part, yellow part, and the blue part. To reduce the size of this picture, we will choose the largest element for every part, where first one is the red part. The largest element is the number 6. So we will choose 6 for the output. And the next one is green. We will choose the largest element, which is 8. And yellow, the largest element is 3. And blue, the largest element is 4. So this is the output for the pooling layer. The next layer is the fully connected layer. Fully connected layer is function to flatten our matrix into vector and feed it into fully connected layer like a neutral network. Okay, this is the diagram of fully connected layer. Actually, in this diagram, it shows two features, where the first one is the left part and the second one is the right part. We combine these features to display the full model. In this diagram, it shows that for input vector, where x1, x2, x3, and x4 will represent as a vector, and it will produce the classified output, which is the first one is the y1, y2, and y3, where we can assume where y1 is the animal, y2 is the vegetable, or y3 is the car. So y1, y2, y3 will give the classified output for the fully connected layer.
Okay, now let's talk about how CNN works, how convolutional neural network works. Okay, at first let's imagine if we have input X or O, and then it goes to the CNN, and then CNN will categorize is it X or O. Okay, how about this one? How CNN determine whether it is the same or not? Okay, let's discuss. As we have been exposed before on the architecture CNN, where the first level is a convolutional layer. So it is core constructing block. It represents as rectangular estimated by the quantity of the pixel. So this is actually filtering. So the purpose of filtering is as move over the photos effectively test for patterns. So here we can see calculation which 1 times 1 the pixel times with the pixel, this is actually the convolutional method. And then when the train image those peaks change and return the excessive values 1. The mistakes of the excessive peaks value let the network expect content of the image. Okay, here is another example where the multiply of each pixel by the value of the corresponding pixel in the image. So here's are the output from the calculation here. So this is convolutional method calculation. So CNN is actually doesn't know the match of the pattern, so it tries everywhere and every possible position. And this is another example. Consider an image illustrated by 5 times 5 matrix. So here's number 1, taking 3 times 3 symmetric and calculate the value. So number 2, 3 times 3 is instructed to write and write down to complete the image. At the end is combo characteristic is achieved. Okay, and the next level, which are pooling layer. So pooling layer is a walls that input into a fix of non-overlapping rectangles. So outputs a value for each sub-region. Two primary layer, max pooling yields the maximum estimation of the sub-area. So average pooling yields the normal estimation of a sub-district. So a main advantage of having less spatial data to gain calculation execution, having less spatial information implies. So why it is having less spatial data? So here is an example. As we know that pooling, it will take some like rectangle area here, the largest value, so it will shrink the large image to the smaller one. So this will reduce the computational load. So it's a best practice too. Okay, for activation layer, applies ReLU, rectified linear unit. Observe growth non-linearity inside CNN. So images are manufactured from different gadgets that are not linear to each other. So here's the example for the ReLU implementation, where the negative value will change to 0. So this will make the CNN calculation more behave, which any value which is near to 0 will avoid from become infinity. And then fully connected layer, so flattening the image. So reworking the whole pool feature map matrix into one column, then being used by neural network for process. With the connected layers, the tendency to combine these options to form a model. Activation function like softmax or sigmoid to classify the output. This is another example of X and O, where each output have its own votes. Votes is actually expressed as weights and connection strings between category. So each output have its own single list. So fully connected value is actually high level filtered image and take the votes. So the answer with the most votes will declare the category of the input. So here's that will be gone through by the input. When the CNN receive the input, it will goes from the lower level CNN until fully connected layer. So then the most vote will determine the category of the input.
Hi, my name is ATHIRAH MANAF, and today I will be presenting to you the application of convolutional neural network, or as known as CNN. Okay, from the study we have identified CNN is applied in a various domains such as the medical fields. So in this video, I will enhance you how CNN works, or how CNN helps in medical fields. Okay, in medical fields, I have identified CNN is work efficiently in a radiography. It will help many identifying disease in radiography. Okay, let's take a look. Okay, the first three example in radiography is the lung nodules. Okay, lung nodules, CNN will help to identify the nodules is benign or malignant. And the second one is the tumor. In the tumor, this CNN will help to identify is it a tumor or not in using medical images such as MRI. And the third one is the tuberculosis on chest, to detect the pulmonary tuberculosis on chest, to identify it more efficiently. Okay, let's go deeper. The first one is the lung nodules. Okay, lung nodule will use the classification imaging, which is it's classified the image into a certain category. Okay, for example, lung nodules will identify by categorize it into a benign or cancerous. So CNN will have a training data set to identify the data, is it a benign or cancerous. Okay, the data set will classify it into these two categories, benign and cancerous, and it is used training data set. It is also used a training data set to identify either the lung nodules is a nodules or not. Okay, let's go. Okay, from the example we can see the CNN is classified the images into certain category, which this is why CNN in lung nodules is used as a classification imaging. Okay, the second example is tumor. Tumor is a different based on from lung nodules. Lung nodules use the classification imaging, while tumor use the segmentation imaging. Segmentation imaging is the images will break into many parts and will show the abnormalities of the picture. Okay, CNN will help by providing the tested image to the doctor by calculating the probability of the organ size or organ place. Okay, for example, the doctor will use the medical images MRI by that have go under training of CNN, and these images will really help the doctor to identify either the tumor have to be removed or not. So this is why CNN is important by identifying the tumor using a segmentation. Okay, by using a segmentation, the images has break into many parts, and each part will be study the abnormalities. Okay, so as we can see in the picture, there is many segmentation of one images, and each images will show the little abnormalities. So if we have found the little abnormalities, we can make a conclusion either the patient have a tumor or not. This is why it is very helpful in detecting a tumor. Okay, the third one is tuberculosis on chest. Okay, this is also different from tumor and lung nodules. Tuberculosis use a detection imaging. Okay, by using a detection imaging, tuberculosis is a disease where we also known as a TB. It's a disease where it will spread into the air. Okay, so CNN will use a very large number of data sets, approximately around 1007 data sets, to identify either the patient is having a pulmonary tuberculosis on chest or not, and the data set will be providing by the database. From the data set, CNN will help in manufacturing the images of tuberculosis. Okay, we have known the before year of evolving in this using of CNN, the MRI images is not really helpful because it is not providing you the real calculation of the organ. So in using CNN in tuberculosis on chest, it will help you to identify the organ in the patient body. So doctor will easily identify, and it might be helpful in saving the patient and another patient. Okay, from the images we can see the detection process is by using a CNN, by implementing a CNN in current radiography, the images is more clear, and the doctor will feel very helpful because the images is trustworthy. Okay, this is why CNN is important in medical fields. We will go through the second fields.
Second application of CNN is in the field of remote sensing. Remote sensing is applied using image classification. So what is image classification? Image classification is the process of taking an input and outputting a class or probability that the input in the particular class. Image classification commonly used in Facebook photo tagging, medical image analysis, and remote sensing. So how the CNN work in image classification? For the first step, CNN is always start with input image in the convolutional layer. From the input image, we extract the feature to distinct the testing image. Second step, we apply many different filters to the input image. Proceed to the next step. We apply a ReLU function to increase a non-linearity onto the feature map. Step 4 is done in the pooling layer, which is second layer. For this step, we take the feature map from the first layer, then apply a pooling layer, and then the result is pooled feature map. After that, we flatten the pool image into a long vector to produce the output in the pooling layer to use for further processing. Finally, the last layer is fully connected layer. This is where all the features were processed through the network. And step 7 gave us the final fully connected layer, which provided the voting of the classes that we are after. The application of image classification is remote sensing. Remote sensing is the process of detecting the physical characteristic of an area by measuring its reflected and emitted radiation. Remote sensing commonly used in cameras on satellite, tracking growth of the city, sonar system on a ship. We use Worldview 2 and QuickBird database for building detection application. First step, we input the initial data from the satellite and training the data with accurate number of set. And then the final step, outputting a result with a category of building, dense residential and others feature. That's all for the application of CNN in the real industry and field.
Conclusion: CNN, a class of artificial neural network where CNN exploit on the knowledge of the specific type of the input. Thus, CNN is much simpler network architecture to be set up. From this presentation, we have outlined the architecture of CNN, how it works and its application. There are 3 architecture layers have been discussed, which are convolutional layer, pooling layer, fully connected. Each layer plays different function and works in different way. Application of CNN for radiology has been discussed in this presentation, which it divides the image analysis into 4 categories. The categories are classification, segmentation, detection, and others. Another application of CNN that has been discussed is remote sensing, which applied using image classification and use Worldview 2 and QuickBird database to detect the building. That's all from us. Thank you.